Hi students, welcome again to Lectures Club. Today our topic is relations in set theory, which is lecture number 6 in a discrete mathematics series. The agenda of today's lecture is first we will define the relation and we will understand the concept of relation with some examples, and then we will see how we can denote the relation in mathematics, and finally we will see how can we graphically represent the relation, which is quite easy way to understand the concept of the relation. So let's start today's lecture. The mathematical definition of the relation is let A and B be the two sets. The binary relation from A to B is a subset of A cross B. A cross B is the Cartesian product between the set A and B. So you must have some knowledge of Cartesian product, then you can understand what is relation, because relation basically is also a set, but relation as a set is a subset of Cartesian product of some two or three sets. So now uh, let's say we have two sets, set A and set B. And set A contains two students named Zeba and Zumar, and set B contains the courses, the registration number of courses, or the course code is CS510 or CS520. So the possibility is that Zeba can enroll in both courses and Zoomer as well enroll in both courses. If we take the Cartesian product of both of these courses or both of these sets, by the way, so the Cartesian product of A and B is Zeba can enroll in CS510 and Zeba also can enroll CS520. Similarly, Zoomer can enroll CS510 and Zoomer can enroll CS520. So these are all possibilities that Zeba and Zoomer can enroll these two courses. So A cross B is also a set, contains four elements. Here I highlight the elements. So Zeba and CS510 is the first element of the set A cross B. Similarly, Zeba CS520 is the second element, and Zoomer CS510 third element, and Zoomer CS520 is the fourth element of A Cartesian product B. Now the possibility is that Zeba is not actually registering both the courses. Let's say there is a relation R1. Zeba only enrolls CS510 and Zoomer only enrolls CS510. Zeba enrolls only one course and Zoomer enrolls only one course. So R1 contains two elements, Zeba CS510 and Zoomer CS510. These are two elements in R1. You can see that Zeba, the first element of R1 is also an element of A cross B. And similarly, the second element of R1 is also an element of A Cartesian product B. So R1 is a subset of A cross B or A Cartesian product B. We can write R1 is a subset of A Cartesian product B. So this is the proper definition of relation. So relation must be a subset of some Cartesian product between the two sets, or we will elaborate further examples so you will understand. So let's say there is another option. Zeba enrolls CS510 and Zoomer enrolls CS520. This is also a subset of A Cartesian product B. Similarly, there is another relation R3. Here Zeba enrolls two courses. Sorry, Zeba enrolls one course CS520 and Zoomer enrolls two courses CS520 and CS1510. So these three elements of R3 are all present in A Cartesian product B. So R3 is also the subset of A Cartesian product B. So how we can denote a Cartesian product, or I mean to say, if there is an ordered pair, which is a member of some relation, so we can represent the ordered pair like this. Zeba and CS520 is an element of R3. Why we are writing like this? Because R3 is a set. You can see that curly bracket is here and another curly bracket is here. So R3 is also a set. So all the concepts of set theory applies on R3 because R3 is a set. And there are three elements of R3, Zeba CS520, Zuber CS520, and Zoomer CS510. So if we represent Zeba CS520 is an element of R3, there is an other way to represent this. We will write Zeba, the first element of the ordered pair, then we will write the relation or the name of the set, and then we will write the second element of the Cartesian also of the ordered pair. Similarly, if there is an ordered pair which is not the element of relation, like if Zeba CS510 is not an element of R3, Zeba CS510 is not present in R3. So we will write Zeba CS510 is not an element of I. We will just make a line or we will cross the element symbol epsilon. Similarly, here we are just crossing the R3 relation as well. Now we will see how can we represent graphically a set. Let's say we have two sets. A contains the elements 0, 1, 2, and B contains the elements A and B. And R is the relation from A to B, or you can say R is a subset of A cart is the product B. So how can we graphically represent this relation? So there is a way to write the elements of A on one side and elements of B to the other side, or from the to the right side, and the sets elements of A to the left side and elements of B to the right side. And we will draw arrow from A to B because the first element is from A and the second element is from B, set B. I mean, first element is from set A and the second element is from set B. So we will draw arrow from the elements of set A to the elements of set B. Here, there is a relation between 0 and A. We are drawing an arrow from 0 to A. Similarly, 0 and B, there is a relation between 0 and B. So we will write, we will draw arrow from 0 to B. There is a relation uh, between 1 and A. Here we are drawing the arrow from 1 to A. So this is a graphical representation of A. And vice versa, if we are given this graph, we can draw or we can write the relation from this graph as well. So this is vice versa. There is a two-way communication. You can, in other words, you can say there is a two-way communication. We can write this relation from the graph, and we can draw this graph from the relation. Another method is like a matrix. Here you can see that the elements of A are written in terms of rows, and the elements of B are written in terms of columns. And if there is a relation between 0 and A, we are just writing a cross, or you can also write one. Okay. In this example, we are just drawing the cross because the relation between 0 and A. Okay, so here is we are drawing the cross in the zeroth column and in the zeroth row and eighth column. Okay, similarly, there is a relation between 0 and B. So we are writing or we are drawing the cross at the zeroth row and bth column. Okay, there is another way to represent the relation in terms of matrix. You can see this is just like a matrix. Another example is let A be the set 1, 2, 3, 4, which ordered pairs are in the relation A, B, whereas A divides B. Here we have been provided a condition. We will write those ordered pairs in this relation R where the first element A divides B, the second element. You can see here the ordered pair is given AB. The first element is A and second element is B. So A divides B means the first element is dividing the B, or you can, in other words, the first element is the factor of the second element. To represent this relation in a graph, here I have made two elliptical shapes. You can see in the first elliptical shape, I have written four elements, 1, 2, 3, 4. And in second elliptical shape, I have again written 1, 2, 3, 4. Here, what I am doing actually, I am actually writing the relation R, which is a subset of A cross A. Okay, now R is a subset of A cross A. So I have drawn the elements of A 1, 2, 3, 4 two times. So first graph is representing the element A and the second graph representing the elements B. We will make the relation between those elements from A to B, from elements A to the elements B, where A divides B. Here you can see 1 divides 1. Similarly, 1 divides 2, 1 divides 3, 1 divides 4. Similarly, 2 divides 2, 3 divides 3, 4 divides 4, and 2 divides 4. Final relation. Here we are considering only those elements where the first element is dividing the second element, or the first element is the factor of the second element. Despite if we write A cross A, we will get 16 ordered pairs. Here we are only writing 1, 2, 3, 4, 5, 6, 7, and 8 ordered pairs. I hope you understand the concept of relations and how we can represent graphically a relation and how we can denote the elements within a relation. If you understand fully, so kindly like the video and subscribe the channel as well. Take care, Allah Hafiz.